Previously, we were working with this wallet on the left and our 5000 port blockchain node. We'll be working on syncing this node with the other nodes. For example, syncing the transaction and the blockchain. So from now, we want to write the section for this node to find the other nodes. If there were a Bitcoin network, we'll exchange using P2P, but this time we're going to use REST for data transmission, which is a simple way to connect between servers. Now let's get to writing the actual code. For this, we'll access our utils folder and right-click, then new Go file. We'll name this neighbor. We'll click on OK, and now we've created neighbor.go. We'll call on this neighbor that's stored within our utils folder later on. We want to check this, so to do this, we'll go to Go Blockchain and click on New, then Directory, and we'll enter a directory name cmd, meaning command. Within this command, we'll click on new Go file, and name this main. From here, we'll call on this neighbor.go, and we want to make sure that our tools for utils is working properly. This main.go within our command folder isn't related to any blockchain servers or wallet servers, but this is what we've created right now. Let's go back to our neighbor.go. First, we want to check if our host port is up and running. For this, we'll be creating a function called isFoundHost from now. For our host, we'll pass in our IP address, which is a string, then port, then uint16 as our argument. Then to check if it's up and running, we'll want to return bool. Then for our target, we have fmt sprintf, and then we connect the address and our port. So this will be host and port. For accessing this, we're writing our target. Then next, we want to write error, and for this, it will be net, then a function called dial timeout. First, we'll specify TCP, then target, then timeout will be time second. So against this host and port, we can confirm if a connection has been made with TCP. Let's look into dial timeout now. We specify TCP as our network, then we have address and timeout. For the connection, we aren't doing anything, so that's why we use underscore. And then we return an error. Let's go back to our code, and if with this address nothing is up and running, then in this case, we have target, then we want to display the error content. Then next would be return false. If it is found, then we'll return true. Now that we've gotten this far, let's go to our main.go. Then we'll import our utils. After this is func main followed by utils is found host. For example, we'll put 127.0.0.1. This is yourself, then the port number, which is 5000. We'll write fmt println and we'll display our result. This is what we have so far, and right now main is in gray. So we'll change our package name to main. Our sort wasn't in alphabetical order, so we got a syntax error. Next, we'll run the program with this. So we'll access edit configurations. We previously used blockchain, so we don't need to use this. So let's rename this to cmd. And for our directory, we're going to refer to the command that we just created. We'll select this folder and click Open, then Apply. And here we have blockchain server and wallet server folders, but let's rename these as well. We'll rename this to blockchain server 5000. And then for this wallet server, we'll rename it to wallet server 8080, which was the default. For our blockchain server, we're going to use 5000 and 5001, so we're going to copy this folder. Then we're going to use 5002, so let's copy this once more. Let's rewrite the 5000 to 5001, and for our argument, write port 5001. Our next folder will be named 5002, and for the argument, we'll write port 5002. We'll click on OK and select Command, which is what we just created. So let's run this program when we don't have blockchain servers running. And when we do, we get the result 127.0.0.1 5000 connection refused, and it's returned false. Next, let's start our blockchain server 5000. With this, our blockchain server 5000 is up and running. Now we'll access our command and run our program again. When we do, we see that this doesn't result in any error. We see true. Right now, 5001 isn't running, so we'll change this to 5001 and run our program. We get connection refused. We'll start our blockchain server 5001 and select command once more and run our program. Now we get true down below. This is how we've added on our isFound function within neighbor.go. Let's stop our web servers for now and create one more function. Let's say we have a blockchain node that's 192.168.0.10. If you are able to prepare a few nodes, you'll have different IP addresses. You could search for IP addresses that are nearby, or say 5000, 5001, 5002, and 5003 and make the port numbers different, but use the same IP address. We want to create a function where the program can search for the nodes that are nearby. First, let's start off by creating some space here to work with. And we'll write func find neighbors followed by your own IP address. We'll pass this in and include our own port. Then start IP uint8. For example, let's say in addition to your own IP address, we want to search for 3 other IP addresses that are nearby. We'll write start port, and for example, this could be 5000 and ask for it to search up to 5003. These are the values that could be passed in. And for our return, we'll return the host address. This is the kind of function that we want to create from now. First, we'll write address followed by fmt sprintf, and with this, we're creating the address for yourself. That's why we'll need my host, my port. Next, we're going to be doing something that's called a pattern. I'm going to display a pattern that I already wrote here. For example, if you go to Google's website and search IP address regex, you'll see websites with the IP addresses written like so, and so you could use these. This section is 192.168.0 and 10, and you can see if it matches or not. For example, here this is 192, and here is a dot. There's the next one and another, so a total of 3. And last, after the 10, we don't have a dot, so we don't have any regular expression. We'll be using this pattern, so we'll write pattern, find string, and with this, we'll be able to find the IP address that's an exact match. But for this one, let's use submatch, followed by my host. With this, what can we search? We can search this 192.168.0.10, but we have submatch, so we can search sub-expressions. This means this 192.168.0 is also subject to comparison. Then this very last 10 is also picked up. We'll cover this later, but we'll set this as our prefix, and this will be our last IP. We'll add 1, add 2, and find the IP address. Now let's try this out. If we don't do matching, then we'll do return nil, then prefix host. This is followed by M, and what's picked up the second time is this 192.168.0. This is followed by last IP, which will be M, and then the last number, so it will be 10. This 10 is a text, and later on, we want to handle this as a number. So let's write str.conf and make this an integer. We'll make this an integer, so there are 2 return values. We'll say no errors, and we pulled out prefix and last IP. Next, we want to write neighbors and make an empty slice. This is how we'll write make, and then we'll write for port, start port. For example, this could be 5000. Then end port. For example, 5002. We want to search up to this point, so we'll write port +1. Then for IP, we'll do the same. Start IP. For example, this could be 0, and that would mean it's only 192.168.10. If we want to say this plus 11, 12, 13, we want to say end IP and IP plus 1. Then guest host. fmt sprint f %s %d, then prefix host, last IP plus int IP. Once we've generated our IP address, next is target. This section is similar. We have fmt sprintf %s %d, then guest host, port. Then we have guest target. If this guest target isn't your own address. For example, let's say you're 192.168.0.10.5001. That's your own address, so you don't have to search in that case. And we'll use isFoundHost, which we just created, and to this we'll include guest host and port. If it's found, we'll say neighbors and include it in append. So in append, we'll include neighbors and guest target. Then last will be return neighbors. This section may have been difficult to understand, so let's actually try this out. We'll go back to our main.go. And we have here isFoundHost, but we'll replace this and find neighbors. Let's say your own address is 127.001.5000. And you want to look at your address 0 and also 1, 2, 3. And also look at the range port 5000 to 5003. Once we've gotten this, we want to start our blockchain server port 5000. And do the same for our 5001 and also our 5002. Then after this, we'll select command and run our program. And when we run our program, we see down below 127.001 plus 1, so 2. We also search 3 and 4. We also search 5001, 5002, and 5003. We see that 127.001, 5001 and 127.001, 5002 are returned. Your own address is 127.001, 5000, so this address is not returned. The servers nearby this address are picked up. 127.002 doesn't exist, but we created a utils where we're able to search for the IP address that surrounds your own IP address, and is able to search for the IP address that doesn't include its own. Now let's move on to our next lecture.